composition of functions. This is the one you weren't quite so sure about. So let's try this. Let's use f of x, make a new function for it. 5x minus 2. And let's use g of x, and also a new function for this one. 7x plus 3. So when we start this concept of composition, it is really the idea of taking one entire function and putting it into the x of the other function. And we have a notation for that. When I say that, you might recognize that being somewhat familiar. The notation for composition is f, and it's an open circle g of x. That is our notation when you read that of composition. This open circle might be a little bit familiar to some of you, except for some of you it's probably been a year since you've seen some of this kind of concept. That being said, another way of notating this same thing is to say the function that's listed here, the f function, will then have put in its x value the entire g function, so we might read this as f of g of x. F of g of x. And so you have one of the two options that we could work with. And I think at this point, if we're looking at doing function operations, could we replace the notation g of x with an actual function? What is the actual function that I can put right here for g of x? Right? So that is another part of the composition step, is we're going to replace this g of x with its function. So now we're almost ready to actually simplify this. The last thing we need to do is actually use this f function and evaluate it. And so we will take and say we have 5, and then it's going to be times whatever replaces the x in the f function, and then minus 2. So what goes in this parenthesis is actually the 7x plus 3. And now we have, and this may be what somebody was talking about earlier, we were talking about distributing. Is that what you're thinking about? Okay, so yeah, then you're on the right track. So we want to go ahead and distribute the 5. Oh yeah. We've got red, we've got blue, let's create purple out of that, because that's how colors work, right? So I have 35x plus 15 minus 2. Subtract 2 from 15. We have 35x plus 13. Does that make sense? Mm-hmm. All right. Well, good. You're shaking your head like, yeah, I think I've got it. Well, let's find out. Why don't you take into G, circle f of x. You do the other one. If you got it, let's see if you got it or not. Okay, some of you need to see the functions again. Let's do this. Clone that. Is it that early in the morning? Come on. Okay, there we are. That might be a help. You like that better? looking like it's supposed to look to you? It's looking like what you have on your paper. That's a better question. So something like, I didn't like what I did. Is that what you got? 35x minus 11. You want to know I can do math correctly, isn't it? Were they the same answers?
No.
I mean, I got the 35x, but were the constants the same? No, they're not. So, rarely will we get exactly the same answer from composition. Sometimes we'll get something very different. But this is this operation composition. How do we feel about composition? Are we good with this? We want to see another example with this? All right, good. We'll see another example with this. Let's try this one. Let's see if we can take when f of x equals 8x plus 4 over 5. And let's look at g of x is equal to 5x minus 4 over 8. And I would like for you to find for me, please, f composed of g of x. I have a feeling we're going to be able to work with fractions on our homework today. Just kind of an inkling on my part. I know your favorite things in the world are fractions. To be honest with you, there's a whole lot of stuff we do with fractions. And I'm going to try to help you understand it better as we go through this year.
Just learned about that fast, though.
Don't you have to make them have the same?
No, you don't have to make them have the same denominator. Hey, is that pen going to be clicked on or off? Just curious. Okay, so we start here, right? Same thing we did before. And so now for the f function, we're going to put in the x position the entire g function of 5x minus 4 over 8. Nice little fraction. So that means this is equal to 8 times whatever that x is, plus 4. All of that will get divided by 5.
Don't you always multiply that on the numerator?
Don't I what?
Whenever you multiply fractions, you want to multiply them in
Nope. Now, in this problem, we need to really think a little bit more about the 8 itself and what it really means. Before I do that, do you have any questions about how I got to this step? Can you see how that gets put together in this way? Okay. Now, I think the question was related to this 8. Honestly, this 8 is actually 8 over 1. Now the question was, don't you only just multiply the numerator by the 8? And the answer to that is, yes, you do, because the 8 is a numerator number also. There's a 1 in the denominator. But many of you notice, if I take 8 and divide it by 8, what is that result? 1. So right here is another name for 1, which hopefully will help us and end up with the quantity of 5x minus 4 plus 4 divided by 5. Because 8 divided by 8 is 1, and 1 times that quantity is just that quantity. Are we okay with that? So what is 5x minus 4 plus 4?
5x.
Because minus 4 plus 4 is another name for 0. And 5 minus 0 is just, 5x minus 0 is just 5x, and we're dividing it by 5. Well, what's 5 times x divided by 5?
X.
Just x. That's very nice.
Okay.
Yes.
For those fraction things, is there going to be questions on the test and stuff that don't work out that way?
Don't work out which way.
Where the numerator is the denominator of each other?
I don't know. It's possible. I need to know how well you can work on fractions, don't I? Then that's how well you like fractions. I could ask you that question and get an essay out of several of you for that. How terrible they are. That's not what my question is. My question is, can you operate with them?
So what would happen if it
Then it didn't cancel out.
So how would you
You want one of those? Okay, we can do one of those. So to the question at hand now. Let's try this. Let's let f of x equals 4x plus 3 over 7. And let's let g of x equals and make sure it doesn't work out. 9x plus 4 over 5. Okay, that'll work. So now let's do composition again, and just for fun, let's do g circle f of x, which is going to be g of f of x, which is going to be g of f of x function is 4 times x plus 3 divided by 7, which is then going to be 9 times the x value plus 4 divided by 5, where the x value is 4 times x plus 3 divided by 7. Question is, does that make sense to this point? Okay. You agree that that is correct composition structure. Okay. So now we're ready for some algebra. Hopefully. Our favorite parts. Unlike the last problem, in this problem, we definitely still want to think about over 1 there, but the 9 and the 7 don't share a common factor. They don't make it become a 1. So I just get to distribute the 9 to the numerator, the 1 to the denominator, and then I separately have the plus 4. So it begins to look something like this. 36x plus 27 all over 7 plus 4 all divided by 5. It's a very nice little fraction. Our favorite things, right? Now, it is important to know that the 4 that's sitting here is actually a 4 over 1. It doesn't share a denominator with the quantity of 36x plus 27 over 7, does it? So, is it possible to take a portion of the fraction and multiply it by the number 1 and still have an equivalent fraction? So if I right now took 4 times 1, would I still have a plus 4 there? Sure I would. So let's multiply it times 1. Is 7 over 7 1?
Yes.
Is that true? Now why would I choose 7 over 7 for my 1?
So that makes the denominator.
So if I consider this part right here, this 7 and that 7 are now the same 7, so they're the same parts, and now I get to actually combine whatever the numerators become. Correct? So now we have 36x plus 27 over 7 plus, and 4 times 7 is 28 over 7 all over 5. I do now have the same parts there, so I can take 27 plus 28, and I'm going to have 36x plus, what was that, 55? Over 7 all over 5. Is that correct? Do we like that, or do we want to make it a little nicer looking?
Nicer.
I'll agree, let's make it a little nicer looking. But first thing let's do, let's go ahead and make that 5 over 1. will look even nicer, correct? Actually, I'm hoping in your mind it really now looks truly like a fraction divided by a fraction. Now I'm going to go back to a question asked a minute ago. Can I take the entire fraction, this entire quantity, times 1? And would it be equivalent to this entire quantity? Okay. So if you're going to allow me to take it times 1, I will take it times 1 in the form of 1/5 over 1/5. Is that black ink 1?
Going to assume so.
Well, I hope so. 1/5 divided by 1/5. Isn't that 1? All right. Now, because we're smarter than the average bear, we know that we can multiply the denominator here because the fraction bar is a type of grouping symbol. And so what is 5 over 1 times 1 over 5? That is actually 1 also, which is the reason that my version of 1 looked like what it did. And now I get to take this numerator times 1 and this denominator times 5 and have an equivalent answer of 36x plus 55 over 35. There is nothing common. There is nothing to cancel. That's it. I'm done. This is what it looks like if your fractions don't cancel out as you go along. Still be done.